بالأحرى هي خلطة غريبة من دم الأبقار وحليب.
Okay, Assalamu alaikum talaba. I hope you are okay and do music for your homework and everything. Today we will talk about the conversion of alcohols to alkyl halide with HX. بله كلام.
کارای 21 و اگزامپل دوباره گرده.
تمام. أبدي خلاص بو و برامن بنا درسته؟
درسته سيد.
تمام. Now conversion of alcohols to alkyl halide with HX. That meaning we have alcohol, okay, and this alcohol it will be alkyl halide. Okay, with what? With HX, with acid. He said here alcohols undergo nucleophilic substitution reaction only if the hydroxyl group is converted into a better leaving group. Why? We know because the OH group, the hydroxyl group, is not good leaving group. We know that. Why? Because the OH, when leave the structure, when leave the molecules, it will be strong base, not stable. For this reason, it will be not easy to remove from the structure. But we can convert the OH group to the best leaving group by reaction with acid. Then, when we say reaction with acid, that meaning the OH group, it will be base. It will be attack the hydrogen for the acid, that meaning remove the proton from the acid. That meaning this process, it will be protonation. Protonation meaning added the proton on a group. That meaning it will be converted to the H2O. H2O plus. H2O plus, good leaving group. It will be easy removed from the structure. This is the idea here. Now look to this. The reaction of alcohol with HX. Now alcohol with HX, that meaning Br, chlor, iodine, is the general method to prepare primary, secondary. Look, primary, secondary, and tertiary halide. Okay, that meaning we can prepare primary, secondary, tertiary halide. Look, this is primary halide, and this tertiary halide. Okay, now this alcohol with HBr. Okay, that meaning this here the OH group, it will be attack the proton and remove this the Br minus, it will be attacked by or SN1 or SN2, dependent on what? Dependent on the structure of alcohol. If you use the primary alcohol like this, that meaning the mechanism it will be SN1 or SN2, if you remember that. For a primary alcohol, the mechanism it will be SN2. Why SN2? Because it is easy to attack this Br nucleophile is easy to attack the carbon. Okay, because there is no many groups on the carbon, yani no crowded. There is less steric effect. Okay, when you use tertiary alcohol like this, tertiary alcohol, look to this carbon here. This carbon is crowded. Okay, crowded, and steric effect. That meaning the chlor, it is not easy to attack this this carbon to remove the OH. Then it will be by using SN1. We know SN1 is two-step mechanism. Step number 1, carbocation formation, and then step number 2, the nucleophile, it will be easy to attack the carbocation. Okay. Here the idea we take it that we take this yani before that. More substituted alcohol usually react more rapidly with HX. Okay, more substituted alcohol, it will be react more readily with more rapidly يعني أسرع. Okay, with alcohols. Why? Because the stability of the carbocation, we know. Look this OH. If we make carbocation, it will be primary carbocation. This, it will be secondary carbocation. This is tertiary carbocation. Tertiary carbocation, it is more stable. More stable, that meaning need just less energy to convert to product, okay? But primary carbocation need high energy to convert to product. Now, for this reason, the tertiary alcohol, it will be react more rapidly with HX. And look to this, draw the product of each reaction. Now, look to the product. Now, this HCl, and we have tertiary alcohol. It will be react with HCl. What is the product? Just remove OH, put Cl, okay, and plus H2O. Any mechanism this? SN1 or SN2?
SN1.
Good, SN1. Look to this secondary alcohol with HI. That meaning the product what? Just remove the OH. With this H, it will be H2O, yes? And put the iodine here, okay? Also this by SN1, because it's secondary alcohol, it will be react by SN1, not SN2. Look to this, alcohol this, also this secondary, primary, tertiary, N1, also this secondary alcohol, okay? That meaning also it will be react by SN1 or SN1 mechanism. To give you what? Just remove the OH, this, remove this, put the Br plus H2O. OH, it will be removed with the hydrogen as H2O molecule. Now look to this, we talk about the mechanism. Two mechanisms for the reaction of alcohol with HX. We know, or SN1 or SN2. How does the reaction of an alcohol with HX occur? طبعا acid-base reaction are very fast, we know that. So the strong acid, okay, protonate the OH group of alcohol, okay, forming good leaving group, we know that. And good nucleophile, okay, the conjugated base of HX. That meaning this strong acid, he said here, look, strong acid, this strong acid, okay. So the strong acid protonate the OH group. That meaning the strong acid give a proton to this base. This process meaning a protonation, okay? Protonate the OH group. That meaning give a proton to the OH group. Or this process, it will be protonation, okay? For the OH group of alcohol forming good leaving group. Okay, that meaning this, it will be OH2 plus. OH2 plus, this good leaving group. Plus what? Plus nucleophile. This is the conjugated base for the acid. This acid, this conjugated base. Okay, this conjugated base is good nucleophile also. Okay, good nucleophile. Look here, good nucleophile. Both components are needed for nucleophilic substitution. Okay, that meaning both of them is necessary for the nucleophilic substitution reaction. Okay, without nucleophile, there is no nucleophilic substitution reaction. Without good leaving group, there is no nucleophilic substitution reaction. Okay, that meaning both of them are important. Okay, are important for the nucleophilic substitution reaction. And he said the mechanism of the substitution of X minus or H2O molecule then depended on the structure of R group. Look, he said depended on the structure of R group. If this R group secondary tertiary, it will be SN1. If this R group primary, okay, it will be by SN2. And he said here, look, this it will be at this nucleophile, it will be react with this molecule or by SN1 or by SN2. You can write here SN1 secondary tertiary alcohol, SN2 primary alcohol. خلاص. Methyl and the primary look, he said here, methyl and primary alcohol formed RX by SN2 mechanism. خلاص. Secondary, tertiary alcohol react by SN1 mechanism. And we take the mechanism. Look here, the reaction of alcohol primary. Look, primary alcohol with SN2 mechanism. Okay, he said reaction of a primary alcohol with HX by what? By SN2 mechanism. If you say here reaction of primary alcohol with HX by SN1 mechanism, أو خلط. Okay, this it will be error, mistake. Now take this. We have primary alcohol. This is a primary alcohol. It will be طبعا the first step. We said protonation. Look here, protonation. Protonation of the hydroxyl group forms a good leaving group, the H2O molecule. Okay, this now good leaving group. The second one, this, look, the second one, this it will be attacked from the backside, and this it will be removed by SN2 mechanism. We know SN2 mechanism, one step. Nucleophile attack, leaving group leave. Okay? Nucleophilic again, nucleophilic it will be attacked and from the backside, and the leaving group it will be removed from the structure. Just it will be give you the product. Very easy mechanism. And he said here, look, secondary tertiary alcohol react with HX by what? By SN2? No, by SN1 mechanism. How the SN1 mechanism? Look here. First step protonation. Look, both of them, this mechanism SN2 and this mechanism SN1, both the first step is a protonation, acid-base reaction. You can write here, acid-base reaction, protonation. Okay, acid-base reaction. This step, طلبة, بس just acid-base reaction. Okay, we know. And just the different by the second step. SN2, SN1 mechanism, look, protonation, good leaving group. Okay, now this nucleophile can be attacked from the backside? The answer it will be no. Cannot be attacked from the backside. Why? Because look, it is so crowded. Okay, steric effect. We have a steric effect here, so crowded. How the nucleophile it will be attacked from the backside? Now, what is the another way? The another way it will be remove the OH group, leave the OH group to give you carbocation. Look, to give you carbocation. This carbocation tertiary, we know tertiary carbocation is slightly stable. Yeah. Okay, now as a slightly stable can be formed inside the mixture of reaction. This can be formed inside the mixture of reaction, and then easy to attack the positive charge. Okay, look, it is here full positive charge, not partially, طلبة, full positive, and this full negative. That meaning is so fast. This step, طلبة, is so fast. Okay, just it will be formed and then top give you the product. Okay. This is the mechanism of SN1 mechanism to convert alcohol to the alkyl halide.
سيدة بس بشيء خطوة دمها كيفها؟
أو خطوة دمها كيفها؟
بله.
تمام. Look, we have first step acid-base reaction. خلاص. Protonation. We have here base. We have here acid. The base attack the proton. Okay. Attack the proton, and this it will be leave Br minus. Br minus stable or no?
Not stable, negative, sir.
أظن بس we know the halogens high electronegativity. Okay, high electronegativity, that meaning can make the negative charge slightly stable. That meaning this Br minus طلبة Cr minus I minus fluor F minus, all this negative charge is stable طلبة. Okay, stable, because the high electronegativity for the halogen. Now, and this is good leaving group, yes? This good leaving group, H2 plus, good leaving group. Now, this can be attacked from the backside?
No.
No, why? Because here we have a steric effect. Okay, we have a steric effect. We have 3 R groups. Look, 1, 2, 3. 3 R groups cannot be allowed for the nucleophile to come from the backside. Now, what is the another way? The another way to remove the leave the OH group, OH2 group. Okay, leave it to give you carbocation. Okay, now this carbocation is stable. Yes, it's stable. Why? Because tertiary carbocation. full positive charge. And the nucleophile, this is the nucleophile, easy to attack the carbocation. Okay, easy to attack the carbocation to give you the product. واضح؟
بلى سيد.
Okay. Look, we said if you have carbocation, always think about the rearrangement. If you have tertiary carbocation, there is no rearrangement. Okay, but if you have secondary rearrangement, and the secondary carbocation can be happened to or can be converted to the tertiary carbocation, do it. Okay, directly do it. Don't think. Okay, look here, carbocation rearrangement in SN1 reaction, because carbocation are formed in SN1 reaction of what? Secondary and tertiary alcohol with acid. Carbocation rearrangement are possible. صح كي؟ are possible. يعني محتملة. As illustrated here in this example. Look, this with HBr. Okay, now this alcohol, secondary, tertiary, primary. Okay, it is secondary. Secondary. That meaning SN1 or SN2? It will be
SN1.
Okay, by SN1. SN2, there is no reaction by SN2 because here is
Primary.
okay. Then this, the first step we know. The first step is acid-base reaction. This unshapered electron on the oxygen, it will be attack the proton. Protonation, acid-base reaction. Okay, attack the proton to give you OH2 plus. OH2 plus. Then next step it will be leave the structure to give you what? To give you here. This positive is secondary carbocation. Now this secondary carbocation can be converted to the tertiary. Yes. Just this, the hydrogen bond. This the hydrogen with hard electron with both of the electron is 1,2 hydride shift. Okay, 1,2 hydride shift. The positive it will be come to here to give you tertiary carbocation, and then the negative Br it will be attack the carbocation to give you the Br here. Okay, look the Br here now, not here. Okay, why? What is the reason? Because the rearrangement of. Okay, and this as I explained for you before that. Look, attack protonation. This it will be give you secondary carbocation. Secondary carbocation. Next step 1,2 hydride shift. Give you tertiary carbocation, and the Br it will be attack the tertiary carbocation to give you the product. Okay. Always just think if you have secondary carbocation, look, it will be tertiary or no. If there is any possibility to make tertiary carbocation, do it. Directly do it. Okay. Now here the homework. What is the major product formed when each alcohol is treated with HCl? That means you have this alcohol with HCl. You have this alcohol with HCl. You have this alcohol with HCl. That meaning all this it will be by SN2? No, because all of them it is not a primary. It is secondary and tertiary. That means all of them it will be SN1. SN1 carbocation هيا هيا زين هكا هيا secondary هكا secondary واحتمال دبنا tertiary تشيكا. Okay, if you have
rearrangement مناسبة.
بله
يا بي و سي rearrangement هاي وهاردوكا.
هيا هاردوكا هيا.
بس يا عينينا هنا.
يا عينينا عافية.
بخو tertiary.
دعوة تظاني.
سيدا أو إيش يا بيبا وسيكولبونن. تحكي
يعني بسنة هي مانا؟ نبزح متى يعني بس أحكم ستراكشر وكيتا أظن rearrangement هي عنا. Okay. Now, if you but just you have to understand the principle. مبدأ تشيا وخلاص. All if I give you now 100 structure, you will be no. This it will be rearrangement هي. This it will be rearrangement. No. This it will be SN1. This it will be SN2. If I give you 100 structure. Okay, it is easy. Just I know to understand the principles. Okay, المبدأ شيء وخلاص. Okay, now reaction of ethers with strong acid. Okay, now we finished from the alcohol. Now we have ether. Okay, he said here from this chapter from the book, ether have poor leaving group. Yes, poor leaving group. so they cannot undergo nucleophilic substitution or beta elimination, yeah, reaction directly. Okay, instead, they must first be converted to a good leaving group. It is like OH group, okay, not good leaving group, by reaction with strong acid. Look, it is like alcohol. The first, it will be react with acid-base reaction to give you good leaving group. Okay, and he said only HBr and HI can be used. Okay, not chlor, not chlor, HCl يعني, can be used. Because they are strong acid that are also source of good nucleophiles. Yeah, this is strong acid. Also, it will be good nucleophiles. When ether react with HBr, HI, both carbon-oxygen bonds. For every ether, how many carbon-oxygen bond we have? How many carbon bond oxygen we have?
دو.
هيا. Okay, هيا. We have طبعا طلبة general structure for the ether are bond oxygen bond R. Okay, that meaning we have 2 carbon oxygen bonds. Okay, we have 2 carbon oxygen bonds. Okay, and he said, look, he said both يعني دو هيا. Both carbon bond oxygen are cleaved and 2 alkyl halide cleaved يعني it will be broken and 2 alkyl halide are formed as a product. يعني ether هيا, the final result it will be 2 alkyl halide. Okay, it will be 2 alkyl halide. How? I will give you here. Look, this is the general reaction. Ether with HX, 2 equivalent, يعني 1 mole for this and 2 mole for this. Okay, 2 equivalent. It will be give you for every R, RX plus H2O. Okay, this it will be RX, and also this it will be RX, and the oxygen will be removed with 2 hydrogen as H2O molecule. Okay, look now, look to this example: CH3 or CH2 CH3 with HBr2 equivalent. Okay, that meaning this Br with this CH3 give you methyl bromide. Methyl bromide. Okay, this Br with this give you ethyl bromide or bromoethane. Okay, bromomethane, methane bromide, ethane bromide. Okay, now plus H2O. Take this compound with HI. Also, this it will be removed with the I, and this it will be removed with the I, and the oxygen with 2 hydrogen atom, it will be H2O molecule. Okay. And here he said HBr or HI طبعا serves as strong acid, give the proton that both protonate the oxygen atom of the ether and is the source of good nucleophile Br minus I minus. Okay, that meaning the benefit to use the acid, number 1, resource for the proton acid, and the second one is the good nucleophile, give you good nucleophile. Okay, and he said to succeed nucleophile substitution reaction occur. That meaning we have 2 nucleophilic substitution reaction to be happened on the ether to give you the final product. Okay, I give you the mechanism. Also, it is same the mechanism for the alcohol. Okay, no, there is no difference. The mechanism of the ether include the SN1 or SN2. Also, we have SN1, SN2. Depended on what? Depended on the identity of the R group. هكا R group primary depend on what? SN2. هكا R group secondary tertiary depend what? SN1. And also he said with secondary tertiary alkyl groups bonded to the ether oxygen, the carbon oxygen bond is cleaved by SN1 mechanism. Okay, involved طبعا carbocation we have carbocation. Always طلبة, always the SN1 with carbocation. And the methyl primary alkyl group, it will be by SN2 mechanism. Okay. Where is the mechanism? This is the mechanism. Look to this mechanism. Look, we have this compound with HI. Okay, now protonation, acid-base reaction. خلاص. عشان put electron on the oxygen to be attack the proton of HI to give you the OH plus. Okay, now this OH plus. Okay, and this he said this good leaving group now. Okay, O plus hydrogen CH3. Good leaving group. Why good leaving group? Because it will be removed as كحول. كحول مستقرة أنها طلبة مستقرة. It will be CH3OH. CH3OH stable or no? Stable. Okay. And give you carbocation here. It will be give you carbocation. This the secondary tertiary carbocation. Now the next step, the halogen, the nucleophile, it will be attack the carbocation to give you the CH3 carbon CH3 CH3 I. That meaning this alkyl halide. Alkyl halide. Okay. Now that meaning what is the product for just if you have طلبة, if you have ether with 1 mole HI, what is the products? What is the product? The product, it will be alkyl halide with what? With كحول. Okay, with كحول, with this كحول here. This alcohol, huh? Okay, طلبة, this. That meaning, if you react ether with 1 mole, 1 equivalent HI, the product, it will be alkyl halide with كحول. But if you have another equivalent for HI, that meaning this طلبة, this كحول, it will be possible to react with another molecule HI or no?
Possible.
Possible. تمام. By any mechanism, SN1 or SN2?
SN2.
SN2, عافية. Why? Because we have here CH3. We said methyl كحول, it will be by SN2. Okay, that meaning the next step here, the next step, alcohol, it will be react with the second mole of the HI to give you good leaving group by SN2. Look, SN2. That meaning the nucleophile attack from the backside, SN2, and it will be removed to give you also alkyl halide with H2O. Okay. The keep
سيدا میگو پاش SN1 پاش SN2
SN1 باش SN2.
و اگه SN2 پاش SN1 خلط اصلا
ما خلطة. كسر اعتراء here. Look, we said before that anyone it will be here we have tertiary carbocation, yes? If you have here tertiary carbocation from this side, this it will be faster. يعني SN1 it will be faster from the SN2. Okay. يعني أول يا سريع ترى تشيك باش يا بطيء.
و اگه هر دو که یعنی بونمونه هر دو که SN1 به فرق نینه منه سیدا
يعني هردو هاوجي فرق نينا.
درسته سیدا.
Okay. But if you have, I say to you, if you have here the alkyl group steric effect, that meaning يعولي SN1 and then go to the SN2. Like this example exactly. Okay? Okay. Okay. I will give you this note. Keep in mind, okay, keep in mind, this bond it will be cleaved by what? This bond? By SN1. Why? Because it's crowded, okay? Crowded, steric effect. And this, it will be by SN2. Why? Because it will be here, no steric effect, okay? Open. Tamam? Okay, I think it is clear. The mechanism, I said general center of the HX. That meaning HX protonate the ether oxygen, thus making a good leaving group. Okay, that meaning we have first step protonation to make good leaving group. And then the HX, it will be source for the nucleophile to attack from the next side. This, the second one. طبعا this final slide is just homework, but anyone he said I didn't understand this. Do you have a question, طلبة, about this mechanism?
بله سيدة أبي دي شيء دبرك يا أبا
تو حسنة؟
بله
حسنة. يلا حسنة. Now we have oxygen, carbon, and also carbon from here. Okay, this is ether, yes? Okay, this is ether. Now, he said here, if you have alkyl group, secondary, tertiary, دي بنحكيها SN1 or SN2? حسنة؟
SN1
Huh? عافية SN1. Why? Because it is steric effect here, and it will be give you tertiary carbocation or secondary carbocation. Both of them is slightly stable. By SN2, there is no SN2. For the oxygen methyl or oxygen alkyl, and this alkyl is a secondary primary carbon, it will be by what?
SN2
By SN2. Why? Because from this side is open and easy, the nucleophile is easy to attack from this side. Okay, from the back side. We say from the back side. Okay, now, step number 1, we have ether gel acid. Okay, reaction هيا أنا reaction هيا. What is the reaction? The reaction is acid-base reaction. Okay, خطوة أولية أبي يا طلبة. Protonation of the oxygen atom formed good leaving group. That meaning the handshake of electron attack the proton of the acid to give you oxygen hydrogen plus. This oxygen hydrogen plus gel CH3, it will be good leaving group. Okay, it will be what? It will be good leaving group. Then أمشين بيجن أبا good leaving group. أمشين موسى بيجن.
بله
زين كيش باشترى؟ أبا good leaving group أنا أبا كيش باشترى؟ زين. Then I will give you idea. Now. Look, I said anyone is good leaving group. CH3 oxygen hydrogen or this CH3 carbon oxygen hydrogen. Anyone is good leaving group. أو طب as بيجم one of you he asked me why SN1 and then SN2. Why we check it SN2 and then SN1. Okay. Anyone, look, if we remove CH3 oxygen hydrogen, that meaning it will be CH3OH, كحول, yes?
Yes.
Okay. Now, if you remove CH3 carbon, CH3 gel oxygen or hydrogen, also it will be كحول. Then anyone is more basic.
بوبتر أو جروب بمناسبة.
Then better R group, it will be more basic. If you said more basic, يعني more stable or less stable?
less stable.
less stable. صح كده قلت less. For this reason, we remove CH3 oxygen hydrogen because it's more stable than this R group gal oxygen hydrogen. Okay, you understand? Do you understand what I mean or no? از نظام yes no بله اره
yes
لا سيكوتينا كي هشت
تمام I will give you I will go to the chemo draw. Just 1 minute. Look, we are sharing. This is the sharing. You saw this, yeah?
yes
Okay, yes. Alhamdulillah, yes. Now, take this CH3, oxygen. We have oxygen here. Okay. This. Anyone is good leaving group. If we say this, it will be, look, and we have here, just 1 minute. This, it will be hydrogen. It will be what? it will be hydrogen. طبعا طلبة there we have positive here. Okay. Now if we remove this side طبعا طلبة this يعني this if we remove this as leaving group it will be what? Give you what? It will be this. كحول عافية. كحول كحول. OH أو كحولة معناه. But if we remove this also it will be كحول. Okay, this it will be كحول. 1, 2, 3. Also OH. Now كحول طبعا كحول can be work as acid كحول can be work as base. We know that. Yes? Now, but we have طلبة here we have do unshape of electron 1, 2, 1, 2. Anyone is more acidic. This compound, sorry, anyone is more basic. This or this? This. Okay. This more basic, strong base than this. Okay. If we say this strong base than this, that meaning anyone it will be more stable. عافية. This it will be what? It will be more stable.
More.
Okay. This it will be more stable. Huh?
Çünkü base الويريكيمة وانا.
بس AR group it will be donating to increase the negative charge. But here we have big R group. All of them donate to make this negative charge here or the unshape of electrons strong. Okay. For this reason, this it will be more stable, and this it will be less stable. Then, if we go back again to our example, this. Now, anyone is best to remove this or this?
More stable.
Okay, yeah, more stable. يعني we remove the CH3 oxygen hydrogen as good leaving group. Why good leaving group? Because more stable than this part. Okay. Then we remove this, give you tertiary carbocation. خلاص. Nucleophile attack the tertiary carbocation, give you the product. Now we have alcohol. This alcohol with another mole of HI, to give you also alkyl halide. Look, this it will be attack the proton, give you OH2 plus OH2 good leaving group. The nucleophile it will be attack from the backside. Nucleophile attack from the backside. SN2 to give you also the methyl iodide. Also it is alkyl halide. تمام؟ واضح نوكا؟ Okay. And this homework for you, what alkyl halide are formed when each ether is treated with HBr. Okay, that meaning طلبة, look here. What alkyl halides are formed when each ether is treated with HBr. طلبة very beneficent. هكا 1 mole HBr فرقة, هكا 2 mole HBr فرقة, تمام? But if you want, write here with 2 equivalent HBr. beneficent طلبة very with 2 equivalent HBr. Okay, هكا just 1 mole HBr it will be give you alkyl halide وكحول. بس هكا 2 mole HBr يعني هردو كدبنا alkyl halide. Okay, this it will be give you 2 alkyl halide, this it will be give you 2 alkyl halide, this it will be give you 2 alkyl halide. Okay, you can write here with 2 equivalent HBr. Now explain why the treatment of anisole, this anisole with HBr yields phenol, okay, and CH3, but not bromobenzene. يعني أبا طلبة قال HBr give you phenola و CH3 Br, not benzene Br. Why? This for you. Okay, make the mechanism, you will be know why. تمام. Now
إذا أوجد دو HBr
كيش؟ لا بس إك HBr نادو. This just with 1 HBr. Now just I work. Where's the sharing? This. Okay.